Hello, and thank you for joining us. My name is Randy Reed. I'm the editor and publisher of the Edison Report. Today I have the honor of once again moderating the annual lighting forum sponsored by the National Lighting Bureau and co-sponsored by the Edison Report and the International Brotherhood of Electrical Workers, the IBEW, which so graciously lends us its production facilities and personnel to help make this event so special every year. The panel I'm about to convene will focus on LED lighting as a disinfectant, a relatively new application that is already having profound impacts. Our panelists are Deb Zawodny, a healthcare business development specialist with New Star Lighting, and Colleen Costello, CEO and co-founder of Vital VO. Ladies, welcome. Edison Report has covered, and we will continue to cover, the IP litigation going on in this field of disinfectant lighting, but today we're not going to discuss that. Colleen, let's start with you. You co-founded Vital VO, I believe, in 2012, and you have a bit of a personal story. Tell our audience.
Absolutely. Thanks, Randy. So back in 2011, I was actually doing research in biomedical engineering at the time, and unfortunately my grandmother contracted a MRSA infection, a staphylococcus infection that's resistant to antibiotics. She was supposed to be in a hospital overnight. She had fallen. Unfortunately, we walked in the next day and were told to wear masks and gloves and that she had contracted an infection just from being in the hospital. And unfortunately, she ended up being there for 12 plus days. And I decided, doing my research in biomedical engineering at the time, to do some research into why this was happening. A lot of people assume you go into a healthcare facility and you're supposed to get better. Unfortunately, in a lot of cases, people end up more sick than they were when they went in. And I identified and found that unfortunately, these what are called hospital-acquired infections are one of the top preventable illnesses in hospitals, things that people are picking up there. And so I decided to research why this was happening. Why are all of these infections happening in these healthcare facilities? Really what I identified at the time was that surfaces are playing a really big role in transmission of germs throughout an environment. I'm sure we'll talk a little bit more about that. So actually started from the biology instead of the lighting and was looking at how these germs are interacting with surfaces. Then we assembled an interdisciplinary team of engineers, mechanical, electrical, biomedical, to start to look at solutions that we could address surface contamination. And that's really where we landed on LED technology, because with the advent and commercialization of LED technology, we can now more precisely tune spectrums that we couldn't do before with alternative lighting products. And it allows us to actually target molecules that are in these organisms in really unique and interesting ways. And so that's how we began development and commercialization of our disinfection technologies.
Okay, interesting. What is the science behind it, and how does it work?
Sure, I'm happy to answer a little bit about that. So as I was discussing, we actually utilize violet wavelengths of light instead of ultraviolet. So ultraviolet has been around for a very long time as a disinfectant, typically used in bulb form in order to disinfect. And that's around the 254 nanometer range and a little bit broader than that. How that actually works is it penetrates the DNA of organisms and basically destroys the cell that way. When you move up the spectrum a good 150 nanometers to the violet spectrum, so contained fully in the visible light spectrum, which is about 400 to 700. It's actually a totally different mechanism. So it happens to be that between 400 and 420 nanometers, it actually targets what's called a porphyrin molecule in these organisms.
What's the word?
Porphyrin molecule.
Okay.
It's unique to these organisms, so bacteria, mold, yeast, fungi all have this molecule, and it just happens to hit a resonance frequency with that porphyrin molecule. Doesn't destroy it, but what it does is it actually breaks off what's called too much reactive oxygen species in the cell, ROS, and it begins destroying the cell from within. So it's a much slower process than ultraviolet, but the really fascinating concept is that our human cells do not contain the same porphyrin molecule as these organisms. And so there's no reaction happening in our human cells. So you can have this type of lighting that can be affecting germs, but not be affecting people.
Okay. So Deb, does this take the place of disinfection?
No, it does not, and that's really a misperception that some people think this is a be-all, tell-all, end-all, yet you install it and you never have to clean another surface. It really isn't true. It's meant to be a part of the puzzle, and it's meant that you still need to clean as you normally would, but this is an integrated part that gives you an added layer and additional protection.
Okay. About how long does it take to clean?
Well, depending on whose research you read, it can start to have an effect after 90 minutes. But then if you check after 24 hours, that's the next measurement level. And then after you go on continuously for a number of weeks, then you see the highest level of disinfection.
Okay. When it's about 405 nanometers, can people be under the light while it's cleaning?
That's really the premise, is that it is actually just targeting those organisms that you want to kill and not human cells. So there are certain certifications that exist today. We're always continually learning, as we all know in this industry, but right now there are what are called photobiological safety considerations for thermal, retinal skin, and so it's important to understand that lighting that humans are under are going to meet those certifications, typically done by IEC, sets out those parameters. And so yes, right now the products that are available are safe to be used while people are in the environment, which is really the intention of continuous disinfection. So there are a lot of technologies, not just lighting, that kill germs and disinfect. You know, you have plenty of them probably under your sink at home, but they don't continuously clean. And so that's really some of the gaps and limitations right now in contamination issues, is that you can clean once a day, twice a day, but there's long gaps of time in which germs can multiply on these surfaces. And so the continuous nature of this lighting really adds an additional layer to supplement that intermittent cleaning.
So, please.
Yes, and just to add a little bit to what Colleen said, one of the things that I hear is people calling it LED blue light disinfection, and it really is kind of a misterm, if you will. There is actually available UV lighting that's used for disinfection, and that's been used for quite some time, and it can either be portable or stationary in a room.
And that's non-visible.
It's non-visible, yes, and it is not friendly to humans or surfaces or anything else. And that's typically from 100 to 280 nanometers. The unfortunate thing is as soon as you turn it off or you remove it from the space, the bacteria can start to grow again. And what we're trying to do is explain to people there is LED and disinfection, and then there is UV, and you can have a friendly space for humans and kill bacteria, and then you can have an unfriendly space for humans and kill bacteria. So how do we balance that out?
But the same thing happens with the VitalVio product. When you remove it, it can continue to grow or begin to grow again.
Absolutely.
But when you say it's friendly to humans, again, I want to make sure, so humans can be under the ultraviolet while it's cleaning, but do you recommend that? Because it's a purple light.
It's not really UV. The UV is really the non-visible portion of the spectrum.
Right. So with UV, we know we would clear the room.
Exactly.
Okay. Under 405 nanometers, while it is cleaning over a 24-hour period, would people be in the room? Would people be working in the room? And would that be difficult because of the purple or violet color that they're going to see?
They would absolutely be in the room. That's really the intention of white light disinfection. So in order to try to make it continuous, you're right, Randy, that violet itself, the whole room is going to be violet. And so that's why innovation in white light disinfection is really important, which is what characteristics most of our products have, because it illuminates the room with high CRI and a bunch of different color temperatures, but it also has a high content of violet. So it kind of behind the scenes is hitting these organisms on surfaces, but it also has a bunch of other components of the spectrum that contribute to white, which means people can operate under it.
Understood. So it really is, if I'm in there cleaning as a janitor, I'm seeing kind of white light. I'm not seeing the violet.
Absolutely. There's certainly different ways with control systems that you can modulate the different features. To give you an example, we have installations from 2014 in an HIV clinic at Mount Sinai in Manhattan, and those are significantly immunocompromised patients. So those are the types of areas where you want to try to keep the germ count as low as possible. And so during the day, it's a 9 to 5 clinic. It's in white light disinfection mode, but you can actually add timers so that, and you mentioned a janitor, that as soon as the last cleaning staff leave at maybe 6:15 at night, it can switch into just the violet mode when you don't need the visual acuity in the space.
And would that increase the intensity of the cleaning?
Yes, it would. So it's all dose dependent.
That's interesting you mentioned controls. So Would you see a lot of preset controls for this?
Yes,
Or
absolutely.
occupancy sensors?
Yep, so that even some off-the-shelf basic controls can be really helpful in adding additional value to the disinfection kind of services, if you will. Occupancy is a really good example. So if you want to increase the disinfection, you can increase the dosage of the violet component of light. And so if no one's in there, you really don't need the visual acuity for people to be using the space. But as soon as someone comes in, you can flip it to white light disinfection mode.
All right, Deb, this one's for you. Can you explain to our audience the difference in cost between standard LEDs and these disinfecting LEDs?
Well, it's interesting that the difference between the actual components that create the light and the overall fixture cost can be very different. And we've seen in the market anything from, if you take a basic 2x2,
right,
and we've seen everything from 5 times the cost to 10 times the cost. And with any new technology, that's pretty likely will happen. But as you look at LED when it first hit the market, to make a comparison, a 2x2 was $500.
Right.
A 2x2 now is $50. So there may be...
And dropping.
And dropping.
Unfortunately.
Yes, unfortunately. And there may be, you may see that happen pretty quickly, where you may see kind of a parity between white and disinfection.
Okay. But if you think about, and when you're selling this, you want to look at the cost-benefit ratio.
Exactly.
And if one patient doesn't get an infection, it pays for itself.
Right. It's the safety of the inhabitants of any kind of a space, and I call them fishbowl environments, where you have to be somewhere for a certain set period of time throughout a day. There are a lot of people there, and you might not necessarily have someone cleaning the space constantly or using any kind of disinfection.
So as we've had this discussion, my mind has been focused on hospitals.
Mm-hmm.
That's what I'm thinking of. Where are some other applications and uses?
Well, other places that we're looking, as far as manufacturers, what we look at is we look at common spaces like schools, sports complexes. Airports are another one. They did a study recently where they found the most infectious and bacteria-laden place in the airport were the bins that everybody has to use in the security when you go through the line. So there are all kinds of places that you really could use this, and there's many more applications that we'll be looking at.
Okay. What are some design considerations that lighting designers should take into effect when they're specifying disinfection with white light?
Dosage is really important when specifying for disinfection. When we look at calculating perfect design for optimizing for disinfection for a room, we actually back into what's called milliwatts per centimeter squared, because that's...
Wait, milliwatts per centimeter squared?
Yes.
Okay.
Because that allows us on a microbiology level to determine the amount of dosage going to the germ. So that's kind of how we think about it. We talked earlier about circadian rhythms and eye exposure. For us, we look at what is the germ receiving? What is that milliwatt per centimeter squared? And so you absolutely, just like any lighting design, need to take into consideration the form factor of the room, and height will affect the surfaces. So you really want to understand what are you trying to disinfect, and then target and work with whoever the manufacturer you might be working with to identify what their dosage recommendation is. And typically that's driven out of clinical research. So I know for our organization, we've been doing clinical research for 5 years now. So we know the correlation between the dosage and how quickly we're going to be able to kill certain organisms. And each organism actually has a different dosage level. So gram-positive and gram-negative will be different periods of time. Spores will be longer. And so it depends on the environment. A food processing facility could have problems with fungus, and they would need to have maybe a higher dosage versus a hospital where it might be gram-negative and gram-positive bacteria. So you definitely want to make sure that you're working with your technology provider to understand the dosage requirements for the room. From a fixture level, transmission of diffusers, paints will make a big difference, just like any other lighting. And some folks might want to disinfect mostly on countertop surfaces or the floor or pieces of equipment that are high sensitivity. So you just need to take into consideration that in the design process.
How has this been received from the overall lighting community?
Confusion, I would say, and one of the things we wanted to do today is put forth, maybe kind of put some of that to rest and maybe make it a little more clear. Because as I said, some people are calling it UV and it isn't. Some folks think you never have to clean a surface again. And again, there's just, if people don't understand the technology, they won't use it. When they did a kind of an informal survey of about 100 lighting designers, And they talked about circadian lighting, if you will, or circadian support, and disinfection and a number of other things. They asked why they would not use it or why they might not use it in their design. And the first thing they said was cost. Their clients were concerned about cost.
Right.
The second thing they said is not understanding the technology. They just didn't know how to apply it. So again, I think that's one of the things that we're seeing. There's just a lot of misunderstanding.
So we're still in our infancy. We're still doing the testing, the studying, and a few beta sites. Is that fair?
For our organization, we have had some pretty significant traction in a number of markets. Most of our business is actually outside of healthcare. Healthcare is also a slow-moving industry, somewhat resistant to change, wants infinite data. We've worked with a lot of the top hospitals in the country with product, but we also work extensively in university athletics, food processing, agriculture, horticulture, where mold and mildew can destroy an entire crop. And that happens frequently, unfortunately. And you look at food service and food processing, where you have large brand names that stock price is cut in half because of a contamination.
Sure.
And you have anything from
poultry,
Bluebell,
Bluebell
ice cream.
stopped production.
Yep.
And
it's not just your poultry too. It's cereal, it's ice cream. The germs are beating us, unfortunately. So we find that some markets outside of even healthcare, unfortunately, have a higher urgency to address the problem. And so with our technology, we're down at the chipset level, and so we can modulate the LEDs not just at the fixture level. We do embedded applications in different food service equipment and things along those lines. So it's pretty wide ranging in terms of the applications.
Do you consider yourself or your Vital VO a health company or a lighting company?
We are absolutely a healthcare company. We are a healthcare solutions company. We approach everything from the health aspect. We happen to utilize LED technology right now. In 2, 3, 4, 5 years, I don't know that we might even be using LED technology as semiconductor development advances. We try to find the best solutions for continuous disinfection, which evolve to things like biosensing and control systems around understanding how the germs are moving through the space. So we're absolutely focused on the health aspect.
So we talk about the germs moving through the space. Let's talk about the product moving through the space. Do you work with manufacturers, reps? How do you go to market?
We have a number of different ways we go to market. We primarily work with end users. So our best core competency is the interdisciplinary nature of our team. We have a whole variety of engineers as well as microbiologists that attack these problems from multiple different angles. So it's really not as simple as shipping 100 2x2s and hoping that someone places them in the right spot. It's everything from the development at the chip level, so making sure that we have the best high quality white light disinfection we can make, making sure that when we do work with fixture manufacturers, it's designed correctly and optimized for the best output. Then the room design dosage we're involved in, because again, we take all of our proprietary clinical research and then drive that into how do we design this room for what you're trying to accomplish, all the way through validation, because most of our customers want to do before and after testing, which is pretty straightforward. You're able to do what are called contact plates beforehand, as well as after, and to Deb points, we typically do even out several weeks with those customers. So we primarily work with end users to make sure we understand their needs, and even between hospitals they have different needs. They might have an outbreak in their ICU at one place and another place their oncology suite, and different equipment in the rooms. But we do also work with fixture manufacturers to provide that product.
That's what I want to get to. So you work with the end user, you find out exactly what they need. Now, do you work with a fixture manufacturer and you sell chipsets to them and they build the fixtures?
Chipsets, light engines, yes.
You build those yourselves?
We work with our distributed network of folks on our proprietary components and then supply those to select fixture manufacturers. Our goal is to really protect as many environments as possible because the problem is so big. So we never want to have a customer where we don't have a fixture model that we can't meet their needs. And so that's why we work with a distributed network of fixture manufacturers.
And it really is, as Colleen said, she works with the end user. It really is more, at this point, more of a C-suite owner type of a situation, because they can understand the return on the investment. They can understand the benefits and make the decision if they want to make that investment or not. Along with the manufacturing, you're looking at light engines and chipsets, but what some folks don't understand is you also have to make sure that the transmission between the LED and the surface, that lens material, that you can actually transmit enough through that to actually have the benefit. And that's something that we see that is another misunderstanding. People will ask to put it in a prison, but they don't understand transmission through a 3/4 inch thick piece of tempered glass or polycarbonate
Because that will affect it.
will affect it, yes, definitely. And the manufacturer can't just stick components into a fixture. There are more
Okay.
things involved.
Okay, understood. You talked about blending the colors, so it's not just the 405 nanometers that we're under a white light. What CCT?
Can be a range of CCTs. At the cooler color temperatures, it's typically more efficient because you have you can have violet. At the warmer color temperatures, it's a little less efficient because it's harder to balance out the violet. And when you look at that spectral design, but there's no reason you can't go through a variety of the most common color temperatures. As you get to the more extremes, it becomes a little bit more difficult.
CRI?
Our products are 90 plus CRI.
Wow, good
Yep.
for you. Okay. Closing comments?
Again, one of the things that we wanted to do today, we discussed this, was we really wanted to better explain the technology so that people will at least consider it and at least do a little more research and have a little more education as far as what it is. And really, again, there's so many benefits to disinfection lighting, no matter what kind it is, that there's such a, as far as the health aspect, as far as the return on investment, as far as, really just the general health of the population, when you're exposed to so many of this bacteria that, is resistant nowadays.
Do you think this will take the place of UV? Will there still be applications for UV disinfection?
I think there will be, because as Colleen said, the healthcare industry is a little bit slow to change, and they've used this technology for so long. And there may be applications where UV is still applicable and really a good idea in certain surgical applications. But when you start to look at LED and how far it's come in the last few years and how far it's probably still going to go and what other light sources are going to be developed, I think this will be a developing technology.
Okay. Colleen, closing comments?
I want people to know and understand that there are new tools for them to address the issue of germs, because unfortunately right now the germs are beating us. I mentioned a couple of examples, but it's wide-ranging, and our current tools are really limited to address this. The antibiotic resistance crisis, the World Health Organization cites on par with climate change, and we're not investing in new antibiotics rapidly, and so I want people to know that there are new tools to address it, and to not be afraid about not understanding it, and try to get an understanding, because unfortunately the problem is urgent and real, and lighting is a really interesting and new tool to try to help address that.
Okay. Well, thank you both.
Thank you, Randy.
Thank you.